¿Cómo?是啊，这样哦，可以可以可以。 Hello, testing. Hello, 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 hello. Testing. Okay. Is this the right amount of people in class? Don't think so. Or they already left. Okay. Typical SMUN student. Don't want to answer the question now. Okay. So welcome to MAT103 Calculus 2. So I'll be your lecturer this semester. I am, what's my name? Anyone know my name? Okay, sure. So you can call me Seng. Okay, so Seng is my name. And my last name is me. Okay, everyone see it? Should we off the light or you guys okay? Everyone see it, or do you want me to off the light? Off the light better. Okay. Okay, so you can call me Seng. Okay, so I think we should learn about each other first before we start the class. So I know quite a lot of you through last orientation, and maybe I learn some of you because of friends of friends. Okay, so yeah, so let me introduce myself first. So I'm Kisan. I was born in Sarawak, Malaysia. So how many of you are from China? China. Okay. So you guys are degree transferred? Is it transferred? Change degree? Is it a change degree? No? You started with mathematics? Oh, you started with no, degree transfer. Okay, good. Most of you, right? No, you retake. Oh, you retake. So which intake you're in previously? 2309. You forget. It should be on your student ID, right? Your student ID should tell you which intake you're in. 2109. Okay. So I was born in Malaysia, so Sarawak from East Malaysia. So it's not here. You need to fly 2 hours to my place. Okay. So technically, I'm overseas also. Overseas. So so I finished my high school in Malaysia and up to matriculation. So pre-U. Before I go to Australia to further my study in mathematics. So I take degree in mathematics and I do pure maths courses. Okay, so do pure maths courses and then up to PhD. I stand at the same place. It's ANU, so in Australia, Australian National University in Canberra, the capital of Australia. Okay, and then after that, I come back to Malaysia to work. So the reason why I come back because I have a scholarship bond. So I have a scholarship bond. So I took scholarship to study in Australia. So I have a 5-year bond. Uh, I have a 5-year bond with Malaysian government, but I'm not required to work with them as long as I'm working in Malaysia. Yeah, and actually I didn't expect I would get a lecture job in Malaysia because pure maths is not sort of a high demand in Malaysia. Not many people want to study pure maths. So I would say that the chance is quite low. But I did saw SMUN recruiting people at that time. I never think about applying until one day I met Darren. You know who is Darren? Professor Darren, the book guy. Ever see? Never see. Now there's a professor in our school. If you went to our seminar, I think you will see him appearing. Our department seminar. So he approached me. He said that, oh, SMUM is recruiting people, and we want to develop our QMS. So that's why I'm here. Okay, so my class will be more on pure math side. But if you don't want to be a mathematician, that's fine. Okay, that's fine. That's totally fine. But what I want you to learn is the skill box from mathematician. You add a skill box, a mathematician skill box into your CV. Okay, into your CV. Okay, how to make things make sense, or how to make things rigorous. Okay, how to communicate better. Okay, or make rules easier to follow. Right. You, when you're staying SMUM, do you encounter any problem with communicating with admin? Do you? No. Very good. So far, so good. Okay. Okay, then good for you. Okay. So what's our class here? So where should we start? So how about you? How about you? Anyone of you come because of this pamphlet here? Anyone of you? Anyone see this before you come in? No, none. Okay, let me do a check. How many of you want to be a mathematician after you graduate? I see. Good. Okay. How about computer science? Computer science. Any computer science? Someone. One. Okay, good. Finance? Finance? Two, three, four. Okay, good. What else I haven't asked? Teacher. Teacher. One. One teacher. How about the rest? What do you want to be? Huh? Still confusing. Good, very good. That's why you come to school. Okay, that's why you come to uni. So you need to figure out while studying, taking this degree, you need to figure out why you are taking this degree. Okay, otherwise you will get lost and lost and lost. So you need to figure out, keep figuring out. Ask your friend why they want to be mathematician, why want to be teacher, why want to be finance, why want to do computer science. Okay, ask them. Okay, take advice. Okay or not? It's okay to be confused, but go and talk more to the others. Okay, so as you all know, do you know what's the degree name you graduate with? After you graduate, what's written on your degree? Mathematics and applied mathematics. Okay, so that's why in our course, you not only need to do pure maths courses, you also need to do applied maths. So for example, what? Statistics, probability, okay, and then in future you will have any courses like combinatorics, and then what else? Optimization. Okay, for pure maths, you have a few mainstream like algebra, okay, analysis. Okay, you have to take up to second year. So until second year, you will have to do two pure maths compulsory, two or three, two for first semester, analysis and algebra, And then second semester, you need to do analysis and complex analysis. Okay, so 2. And then you have freedom to choose your ME. So ME is a place where you need to decide, oh, after degree, you need to go computer science. Then I take computer science ME. If you want to go maybe physics, you also can do physics. Take physics ME. Or if you want to do pure maths, then take pure maths ME. If you want to do finance, okay, you can take financial mathematics. And what else? What? Economics, yeah, economics also works. Okay or not? Okay, so first year is a basic. Okay, so we prepared you, okay, to go into different field. Okay. As you met me, I will be more on pure maths. Okay or not? Not focusing on arithmetic. You know what's the difference between mathematics and arithmetic or not? Do you guys prefer English or Mandarin? Mandarin. So honest. Mandarin. Okay. I mean, of course, I cannot speak Mandarin here. Okay. Truly Malaysia. Okay. Of course, sometimes maybe I will use some Mandarin. Okay. Maybe I scared you cannot understand some English term or very important, then I will speak in Mandarin again. But in principle, we will use both. Okay. Dual language. So where did we solve this now? Arithmetic, thank you. So arithmetic and mathematics. So usually, as myself, I am a student from Malaysia, right? Okay, before university. So why I am good at mathematics. I think again, why am I good in mathematics? I think I just know how to calculate. I didn't really know why I'm calculating. Because when I go to university mathematics, I found that mathematics is not about calculation. Okay? It's about proving. Wow, everyone had this word of proving. Do you get headed or not if you heard this word? It's same to me for the first year. Same to me. Okay, for the first year. Because why I choose mathematics? Of course, I don't want to write the essay, right? English essay, I don't want to write. But turns out to be essay again. Okay, no choice. Again, for me, I have no choice because I still like mathematics. So I learn. Okay, so meaning I am also learning from zero, from nothing to something. Okay, so you should be able to work it out also. Okay, so arithmetic is most people know. So in Chinese is 算术. So we need to differentiate between arithmetic and mathematics. 数学和算术. Okay, no? 算术和数学. Okay, so in our class, we will focus on 数学. But we won't forget 算术. Because arithmetic is you learn set theory. What do you think? What's the relation between arithmetic and mathematics? Can you use set theory language to talk about this too? Yes, arithmetic is a subset of mathematics. Okay, 你要会算先，等你会算了，我们再想为什么这么算。Does it make sense? Make sense, Okay. So my class is quite different from the others. You will expect a lot of first time here. 什么意思？你们第一次要留给我的哦。Okay, first time you will experience a lot of first time here. Of course, I'm also giving my first time to you, right? Am I first time meeting you? Right, I'm first time meeting you, right? Okay, so 我们都线上我们的第一次 Okay. Yeah, actually it's quite interesting. I mean, quite exciting for me this semester because I finally left the 2 batch that I start for last 2 sem. So I was teaching the 2304 and 2209 for 2 semesters. Yeah, this semester I took entirely new classes. Hopefully, we will work well together and have a good chemistry. And so, my intention will be for you to learn, learn a lot as much as you can. But at the same time, I think you will learn it quite hard. Okay, it's very hard. I acknowledge that. Again, math is very hard. Okay, so you can think of this as a staircase. Week 15, Okay, 15 weeks only. Stay for 15 weeks. Okay. After this 15 weeks, you will see very nice picture. Okay, you will learn a lot. Okay, you will see a nice paradise here. Okay, the backdrop here. It's a bridge for you, paradise for you. 海滩是你的乐园吗 No. If not, you can replace your paradise. Beach is not important. Okay, important is the paradise. Okay, yeah. By the way, in Malaysia, there's a lot of nice beaches you should go. All right. Let's see. Where should we start? I think you guys are quite okay with this. So there's something we need to align first. Let me see which one should we go. Okay. Okay. Before going to that, I still want to emphasize that what's my class focusing on? There are 4 keywords here. You should remember. Okay. So first is about freedom. Okay. You need to ask me, well, this question have to do this way or not, that way or not. No. As long as it makes sense. Okay. As long as it makes sense. Okay. You need to be as able to explain what your step is. I think you experienced this last semester, right? You need to justify why you write your step. Third thing is about rigor. Okay, will be very rigorous. Start from definition. Okay, definition and then examples and then theorem, proof. But in this class, not much proof. Okay, we cannot do too much proof here because still this class is a mix of calculation and theory. Okay, not much proof, but we will prove as much as we can. Lastly is about clarity. Okay, so if anything unclear, you must ask me. You must ask me. Okay, you must email me, ask me in Teams or so on. Okay, no, don't hide to yourself 这个老师教不好啊，什么啊，不用 complain 的，我们有问题我们一起解决。OK 了，我来不是要害你，我就是来解决问题吧。Of course, there's a lot of things you don't know or you never done before. You are weak at. We are here together, okay, to work together, to grow, okay, to change. Most important. All right, so talk about this clarity. Maybe we can start with some administrative information. So how many of you have looked at the Moodle already? You browse to Moodle? Okay, good. So have you seen this course information document in first week? Okay. So anything I will update there formally. Okay, if there's any big changes. So this semester is 2409. Okay, 202409. MAT103 calculus 2. And this course is 5 credit hours. So this 5 credit hours is important for us to set the assessment. So in this course, you will have assignment, project, and presentation. This is my email, first name and last name. Okay, feel free to email me if you need anything. So our class is Wednesday, Friday, 1 to 3, 9 to 12. Still reasonable this class time. Okay, I have another class at 7 to 9 p.m. p.m. Okay, not a.m. So okay, I will talk about class structure in a moment. Office hour. Okay, this office hour is very important for you. So one of them is you can make appointment with me. Okay, the other is I have my office hour on Tuesday 2 to 4, Wednesday 3 to 5. You can check your timetable. I call it pure maths first aid stop. Okay, what does it mean? So in this timing, right, I'll be there. Your senior will be there as well. Okay, so if you have problem with your assignment or lectures, you can go there and ask. Get help. Okay. Get help for your assignment. If you don't know how to do your assignment, go and get help. Okay, don't keep it to yourself. Does it make sense? Okay, so you can get help for your senior and you get help from me. I'll put every week venue for you. I think mostly is at the A4 meeting room just beside here. Okay, but I will make announcement every week. So I purposely put a pure max here. Yeah, of course, you can do it for calculus too, and maybe you have other problems, you can also bring there also. So general pure max, I can help if I can. Okay. So, so there are textbook and suggested reading I put on the Moodle also. Okay, you can download. And this time I upload everything for you. And I even upload the solution manual, right? Did you see it? Okay, so make sure after lecture, okay, take some time practice. Mathematics needs practice. Like what we said just now, arithmetic, right, is a subset. So you still need to know how to calculate. Uh, you want to study mathematics is actually easy. Okay, why is it easy? You need to know a lot of examples. Okay, you cannot just know concept. 不能纸上谈兵. Cannot. You need to do a lot of exercise. Do to a stage that you understand the concept. That's all. But this level, depending on people, maybe some of you need to do like 10 questions. Maybe some of you do 3 questions done. Yeah, this one depends on people. Okay, you need to put your own effort in. Does it make sense? Okay. Yeah. But the main reference we'll be using is Stewart. Okay, Stewart and Adam, these two. Okay, so these are the two main reference. The other is a extra reference. Okay, so we have a lineup for 1, 2, 3, 4, 5, 6, 7, 8. 8 chapter for you. Okay, and when we run through the lecture, I'll tell you which one is important, which one just for extra reading. Okay, because one problem with this university is they put too many chapter into the syllabus. Okay, and then we just cannot finish everything. Okay, so we need to pick and choose for some of them. Okay, so the principle of pick and choose is I teach you the basic until that you can apply to different branches. That's all. Okay, I won't go into different branches. It will be too much. Okay, so we will focus on basic, such that next time if you want to use the basic again, then you know how to use it, how to apply. Does it make sense? Make sense? Okay. Okay. So in this courses, we have 5 assignments. So there are timeline here. Okay, almost every 2 weeks we have a assessment. So usually last year we have 3. So why we have 5 here? Because I want to break the 3 into 5. So you could expect maybe shorter a little bit. Yeah, so I don't want to like lump some into 1 week. Okay, so we consistently break into different weeks. So for maths, unfortunately, we don't have like AI or other computer science or engineering project. Most of us are doing assignments. Okay, because assignments helps you to see a lot of examples and then you will understand the concept. Okay, project. So there are 2 projects here. So for these courses, I have talked twice already. I think it worked well. So we said 2 projects. One project is based on pure maths. The other project is based on applied maths. So you can train these 2 components. And the presentation will be for the applied one. Okay, so it is at the quite end of this semester. Okay, so we will run through the criteria of the project again next time. Maybe not now. And you will have a midterm test, 2 hours, final exam, 40%, 2 hours. Okay, this one should be very normal, common. So for these assessment, each assessment is very important because each of them contribute to your final score. Okay, so I don't want you to like take easy on them. Okay, please put effort into it because the mark you get each time basically set what you get in the end. You can calculate, right? All of you mathematician, right? Okay, so if you want to get, for example, 3.2, how to get 3.2? Meaning, on average, every assessment you need to get about 3.2 marks. You cannot say, oh, assignment I get 2 only. But sir, why my grade is 2, not 3.2? Because most of your assessment is just 2 on how to get 3.2. Correct? Okay, so if you want to get score high, please put effort into your actually assignment, right? Okay, assignment, project, presentation. These are main component. So 35, 40. Okay, main component. And then this one is giving you time to think. Give you time to search for material. So make sure you score 100 here. Don't miss it. Yes. Oh, very important. Everyone asks about group project, whether individual or group. Individual. Okay, both project will be individual. Okay, no. Okay, both project will be individuals. Yeah. Okay. Yeah, you earn your own marks, basically. Okay, you earn your own marks. Okay, any question about this assessment? If can, I will release the assignment one this week, maybe today or Friday. Okay, but we will have less time for first week, so I think maybe we'll extend it to Monday. We'll see how. Okay, we'll see how for the first one. But for each one of them, I'll give you at least maybe more than 1 week to do it. Okay. Minimum also 1 week. Okay. I will try to release assignment earlier each time. Okay, because this way is a bit unfortunate. If you know our Malaysia calendar there's a lot of holiday. Okay, so basically we miss 2 days. Okay, so yeah. Okay. Right. So although this is a tentative one, we will change based on our speed in class. Okay, so first project will be on pure maths, and then second project will be on applied maths. Okay, so for both these projects, I've uploaded the 2 years previous how they do it, the sample for you. You can have a look first. But I'll go detailed next time. Okay, but not today. It's not there yet. Okay, so most important one is the assignment one. It's coming soon. Okay, so we'll finish this. So some update for you, maybe. So it's a few more rules. So our course is on the double pass rule. Do you know what the double pass rule is? You know what's a double pass rule? No. What do you need to pass this course? 2 things you need to pass double pass. You know? Don't know. So important you don't know. This is the way you survive in SMUM. If you don't pass, then you fail. Retake. Okay, that is one of the pass. Then there's the second pass. First pass, you need to pass your continuous assessment with 40%. Okay, so continuous assessment, do you know what does it include? As long as it is not test and final exam. Okay, so here got assignment, and then a project, and then presentation. And so here has to be greater or equal to 40%. Okay, and then the other one is overall need to be greater or equal to. Does it make sense? Double pass. Okay. So in SMUN, there's another course called triple pass. What's the third thing you need to pass here? Final exam. Final exam. Okay, you need to pass your final exam with 4. Okay. But here, most of the maths is double pass. Second, I think you should know that your attendance have to be greater or equal to how many percent? 80%. Okay, so this means what? And there's a privilege here. Can you read or not? Can you, from this sentence, can you read a privilege here? Yes. How many classes can you miss? 6, eh? 6. Yeah, right. You see your privilege, you cannot cover. In this 6 class, you can, without telling me why you don't want to come. Yeah. Okay, so there are 6 classes you can miss. But for the others, you need to apply leave from OA. Tell me also no use. Okay, you need to have a formal proof. Does it make sense? Yeah. Yeah. Okay. So we have a few holidays we need to settle. So there are 2 holidays actually we encountered. Both of them are in December. So I think all of them are Wednesday. So it's 11 and 25th. Okay, you can check your calendar. So there are a few times I offer here for this replacement. So can you check your calendar whether you are free on these days or not? Or these are the 2 hours class we need to replace. Are you okay with these 3 periods here? Please check your calendar. Is everyone okay? Or any timing is not good for you? Please check. Okay. If any one timing is not okay for you, can just scribble it out. Okay. Okay. Oh, okay. No problem. Then I will choose between these 3. Okay, because I also need to check the other class replacement also. Then I need to arrange for both. Okay, first one is quite important. I'm not sure how many class did this. I want to pick 2 class right here. Okay, so here I think we have a quite good ratio of boys and girls here. So maybe we pick 1 class rep for boys and then 1 class rep for female. Of course, these 2 were like responsible for all. So what's this class rep do? So this class rep mainly liaison between me and the student. Okay, maybe I have some emergency here, then the class rep can help me to contact all of you, or what? Or if you have any problem, but you cannot speak directly to me. I don't know why you cannot speak, but you cannot speak directly to me. You can speak to your class rep, and then let the class rep tell me. Does it make sense? Okay, now. So can I get a volunteer of a male class rep and a female class rep? One volunteer. Can I get a volunteer? Volunteer. Let's go volunteer. Which one? Oh, volunteer. You need to go Thailand first. Any volunteer? Huh? Hey, university student, hey, don't be shy. What advantages you want? Or you don't know? I need to talk about it. Advantage. This is a real SMUN student. Because the first day I come here, what I experienced was I feel that I've been chasing dream for like maybe 28 years. The first time I came to this school, I feel like these students are so practical, very practical, very materialistic. I can say that. Okay, maybe it's their background, but they don't give me a sense of how to say, maybe studying. Okay, studying. Yeah. So okay, let's come back. So what's the advantages? I don't want to give you false hope. Okay, I don't want to give you false hope. But what's the advantages being a class rep? First, you learn how to talk with people. You know how to talk with people or not? How many here are friends of you? Okay. So this is a very important skill in you learn in workspace. Learn how to communicate with people. Otherwise, we got a professor or lecturer. Every time ask him or her something, he was like very angry like that. This one you also don't know me. Give this kind of face to the colleague. You think people like you, man? Like you or not? Of course not. So you need to deal with these people, and then the other thing is from yourself. Okay, do you like to help people? Wow, my classmate here got problem. Can I help him or not? This one is from you one. Okay, this one I cannot show. Yeah. Okay, no problem, no problem. I didn't talk about that case. It's okay, that's okay. But I need a class rep now. It's my problem. So can you solve my problem or not? Can you help me or not? I got a problem, man. Can you help me? Lecturer also got problem, man. Hey, you don't think lecturer is like a god or auntie or what? Powerful around student. No, not like that. I also got mistake. So you need to point it out. And then we learn together. I'm a human also. Okay, I'm just a little bit older than you. That's all. Okay. Yeah, so I have a problem now. I need a classroom to help me to maybe pass messages to know about this class. Maybe I need to interview you, both of you. Maybe I need to know, what's class thinking about this class, this assignment today, or this lecture today? Are they confused or not? Are they having problem or not? Okay, how can we come up with a better solution to solve it? Okay, do we need maybe extra class perhaps? Okay, or tuition, something like that. Does it make sense? Yeah. So do we have volunteer? Do we have volunteer? Do you want to be one? Okay, sure, sure, good. How about the rest? If not, then I have to assign on. Assign is you cannot choose one already. Now I give you a chance to choose. Hmm? No, 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 not a big deal. Okay, first job. But I want to set up a team group chat. Okay, so we'll start an informal discussion there. So if you want to, what do you want to ask? Actually, you have few ways to approach me. One is through email, right? One is through team message. The other one is through Moodle. Did you see Moodle or not? I set up quite a few forums there. Okay, so you can ask question there. Okay, I put a P-Send question time there. So it's like a prime minister question time. You know what that is? You know what that is? Prime minister question time. So in the parliament, right? So all the MPs, the member of parliament, will have an allocated time to ask prime minister about how he governed this country. Okay, so you will have time. You can also ask there as well. Okay, but I offer another way. Okay, informal group chat. Okay, but this one is about class stuff. Even for class activities, maybe you guys want to discuss about assignment, or you want to have some eating or lunch or what also can. The other one is about this class. Very informal about this class. Okay. Anyone want to be a volunteer? If not, I have to assign later. Don't be shy. Oh yeah, assign. If no volunteer, I will assign later. Okay. Sure. Yeah. Please don't be shy in my class. If you be shy, you will lose a lot of things here. Okay, good. So what time is it? Yeah, I think we should talk about the structure of this course now. Okay, so these are the admin job. So let's talk about structure of this course. Yeah. I think there's a restart there. Okay, I think it's restarting. Okay, good. So there's some viewpoint on lecture notes and what I meant by truth. Okay, so I think all of us have some view on truth. What is true or false inside your mind? Was the first SEM you come in, you learn discrete math, right? So it's very important in mathematics to discern what is true, what is false. Okay, so this is the first thing you should ask yourself. Whenever you see a statement, whether it is true or false or not. Okay, so my first viewpoint on lecture note is you see me using a lot of terminology from politics. So I see lecture notes as a constitution of this course. Okay, so meaning everything you will do in assignment or related knowledge, you should be able to deduce from our lecture notes. Okay, so we will do it very rigorously. So you can check all the definitions and so on. Does it make sense? I say a lot of definitions in this class. So you better be aware when I talk about definition, it's really important. Because if you start with wrong definition, you will lead to wrong stuff. Very dangerous. Okay, so every time we have to discuss definition to make sure everyone on the same page. If you are religious people, we will think of it this as a Bible. Okay? So lecture notes is a Bible or constitution of the course. So we will frequently update if there's a mistake there. Okay, so you need to be aware. There's a date when I update the document inside Moodle. Okay, you should check whether it is a latest date or not. Okay, and how about truth? Okay, what is true or false in this world? Okay, 真真假假假假真真. Okay, in this world there's too many confusing stuff. So let me give you some question here. Okay, give you some question. Question. Which equation here are true? Let's say we use true. Okay. 1 plus 1 equals to 2. 2 1 plus 1 equals to 0. 3 1 plus 1 equals to 10. Or 1 plus 1 equals to 1. Which one is true? I'll let you think for a few seconds. Give you 10 seconds. It's true, yeah. Huh? All of them are true. I said say all of them are true. Why? In different. Okay, can you tell us why? How are they true? For example, A. It's very simple. Very simple. Kindergarten already teach you 1 plus 1 equals to 2. B. Modular 2. Okay, makes sense. Again, in modular 2. So maybe we should add some more things here. Mod 2. Yeah. Is C true? Am I writing? Let me write it properly. Huh? Is it true or not? Is it possible to be true? Why? Can 1 plus 1 equals to 10 or not? What is 1, 0? What is 2? Binary. So in base 2. And in base 2. D. Okay, so you just learned last semester in. Okay, so what I say here is what you have learned before actually. Okay, so if you don't know, make sure you go back and revise your knowledge. So meaning what? Meaning what? Meaning what? So we need to be rigorous when we ask questions. True in what sense? Equation, what kind of equation? Equate as a number? Equate as a modular arithmetic? Equate as a base binary expansion? Equate as a moving modular. So you need to ask yourself, be precise. So the problem here is this question is not precise. Okay. So you need to ask true in what sense? So this is what I mean by rigorous. Okay. This is what I mean by rigorous. So you need to be rigorous in your question. Does it make sense? Okay. So from here, this is why people get confused in abstract stuff. Because there are a lot of details inside a question. For example, people 问这个东西好吃吗？有些问好吃，有些不好吃。有人讲这么好吃嘞，哇，因为它辣，够辣。不好吃嘞，因为它太辣。You know what am I saying? Talking about what to say now? So what is 好吃 for you? What's the definition of 好吃? So if you use different definition of 好吃, then you will lead to different answer. Actually, they are not talking about 好吃, they're talking about 辣. You get what I mean? So this is what you will learn throughout this semester in my class. Okay, discerning what people trying to ask. Question behind the question. If you want to put it that way. Okay, what is the true intention that people want to ask? Okay, does that make sense? Okay, so this is what you can learn from mathematics. This is a really powerful tool. Okay, this is a really powerful tool. Okay, you will see this again and again in my lecture. Okay, so speaking about rigorosity, so my class will be carried out using a way called lectorial. Okay, so what's lectorial here? So this is a combination of lecture and tutorial. Because this is a very special case in SMUL. Only one lecturer pick up all the classes. And then all the classes is either 2 or 3. Correct? Okay, because we are either 4 credit hours or 5 credit hours. So 2 plus 2 or 3 plus 2. So it's a very long process, you know. During my uni time, right, we only have 1 hour. Then we should switch class. Okay, so if you are tired for 1 hour, then you switch class already. But here, no. It's like 3 hour, 2 hour marathon like that. Okay, so in this case here, I need to run my own tutorial. Okay, so I'll sort of combine them together. So what do I mean by combine them? So meaning, we will have a Q&A section intermittently. Okay, so you can ask me, we can discuss. Okay, we can digress to discuss a little bit. Okay, maybe you have a concern. 老师，我一直问，不是打扰到你教书 ？Okay, no worries, I will control. Okay, you ask too much, I will stop you. Does it make sense? And we can discuss afterward privately, if required. Okay. So if you have problem, please answer, because your problem might be the problem for all. Actually, all of you have the problem, the same problem, same question. Does it make sense? Okay, yeah, so please ask. 不要跟我有什么隔阂讲 ，OK， 我要你对我诚实。Does it make sense? OK， 不要藏起来。OK， don't hide everything. Otherwise, I won't read your mind. OK 了，我不是你肚子里的蛔虫。You have to tell me. Does it make sense? Okay. Yeah. Okay. So ideally the flow is like this. Okay. So we will start with motivation. Okay. I'll motivate why we need to learn the theory or how the theory works in normal life. And second, this is the part we want to make things precise. Okay, so we will go with definition first. Okay, or axiom. Okay, so this is the place we start. We have a question. Okay, we motivate. Yeah, how to solve it then? Okay, we define first. Start with definition. And then definition must be useful, right? So we need to have example to support it. Okay, either example, either non-example. Do you know what non-example means? Yeah, Isaac? Yeah, so you can think of it. Example is like satisfying the statement of the definition, and then non-example will be satisfying the negation of the definition. Does it make sense? For example, what? Um, any examples here? What do you want to define? And what do you want to define? What do you want to define? Let me think. Any definition that can works? Okay, actually, I have some activities. I have forget to bring paper. Do you guys have paper or not with you? In front of you? Or iPad also can. iPad also can. Anything you can write on. Does everyone have one? Have one? Okay, let's do some little example here. Let's do a game. Let's do some game. Take out your the tablet or a paper, piece of paper. So let me define this. Okay, now I define a banana. Please draw banana for me. Draw as big as you can. I give you 1 minute. Please draw as big as you can. Fill your paper. So the task is to draw me this banana. Okay, so can everyone like show like this? Show like this. Show in front of you. Can you show to me? Like this, take it out like that. Yeah. Right? Show me. Yeah. Okay. Sure. Take it up. Take it. Lift up high. 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 High. Show everyone. Show everyone. Show everyone. Right? Show. Right? Show us. Please show us. Okay. Anyone? Anyone else? At the back. How about you? Can you show? Hey. Right, good. How about you? Hey, good. Hey, good. Hey, can you keep your banana for me? How about the other one? You? Okay. Anyone I haven't seen here? How about here? The three girls here. Can I see your banana? Yeah, good. How about you? Okay, good. Front one. How about you? Hey, what did you draw? Can you show us? What did you draw? Can you show us? Yeah, can you show us? Can you make me find? Okay, you draw new for me. Okay, good. Hey, can you show everyone yours? Yeah. Wow, very round on this one. Good. Can I see? Hey, good. Okay. How about yours? Can you show us? Yeah, everyone look at this one. What are you thinking about? Good. I think you get me. Okay. Actually, I wanted to describe Apple actually. So what I want to say here is for definition, right? Okay, why is this shorter? So for definition, right? What's important here? The important here is not this name, is what come after this name is important. This is mathematics. Banana is just a name. Maybe you have your own idea. A banana, where will look like apple one, I must roll a banana up. It's not like that in mathematics. We give the definition. Does it make sense? So what's important thing is what come after this word banana. 后面那个才是重点哦，不要听到前面就开始做动作。Does it make sense or not? Okay. The one at the back is the most important thing. Okay, for the definition. Okay or not? So clearly, if you look at this, maybe you might think, this definition have to be wrong. Hey, did you ever see a red banana before? Can you describe for us? Red but not round, but actually quite fat. The one I saw, quite fat. If you can go to Pasar Malam? No Pasar Malam, don't know. Does any Malaysian can explain Pasar Malam or not? Yes, the one outside the Kota Warisan one is a Wednesday, Saturday night market. Okay, maybe you can go ask them, do you have a red banana or not? Okay, there's a red banana actually. Okay, yeah. So anyone that satisfies this definition, we call example. If it is not, for example, what? For example, what? Watermelon. Okay, watermelon. Watermelon is not red, right? So watermelon is not a banana. Maybe apple is a banana, almost. Okay, does it make sense? Okay, no? Okay. So very important definition. Don't look at the first word. Look at what comes after the name. This is the thing we are referring to. We are referring to round, red, round, sweet fruit, not banana. Just that I call it a banana. It's just a name. Okay, so definition, this is how we read definition. So please don't confuse us. Okay, good. So after examples and non-example, we can start with theorem. Okay, so fourth thing we will talk about is theorem. Okay, we will prove some. What's theorem? It's some true statement. Okay, need to be proven. Okay, we collect some phenomenon that hold true for these examples we want to prove. For example, what? 每个男的都是短头发。Can you prove it? Oh, this cannot prove because you found what? Found a counter example. Where is the counter example? So far, no way. In this class, no one. Okay. Right. Okay, so we need to collect a phenomenon and then we try to prove it. Okay, so these are theorems. So theorems, sometimes you will see proposition as well, right? Propositions are lemma, corollary, right? Or some claims. Do you know what claim is? Claim is how to say in green? So claim is some statement that you think that is correct, and then you say that it's correct, and then you prove it. Does it make sense? 我觉得是这样，我不要你觉得。Okay, we need to prove it. Okay, so this is the claim in mathematics. When you claim something, you need to prove it. Okay, otherwise it's false and it's a false statement. 没有人相信你讲的。Conjecture is some statement that haven't been proven and also haven't been proven false. This is conjecture. 猜想。So claim sometimes is what we need to use for the next step of proving. I claim this is proof and then I can continue here. Yes. Sometimes it's very important statement. We will say we will categorize it as a theorem. Okay, but claim is maybe just some normal segment, not as important as theorem. Okay, so there's a level here. So for example, theorem is the most useful or most important one. So maybe I put a level here. And maybe how does the level come down? So here important. And so last one is theorem. So maybe we have proposition. Okay, we deduce a lot of true facts. And while deducing, we might have a lemma. Okay, so lemma is something that we need to prove first before we prove theorem. Okay, or prove proposition. But there are important lemma in the history. For example, John's lemma. And there's a lot of Euclid's lemma. So on. Okay. But this one is just, you can think when they turn this word to the statement, you can somehow think about how this mathematician think about the statement. Sometimes it comes up to be very useful, but they thought it is just something trivial. Okay, so this reflects how people think about statement. But in general, we have proposition, then we have theorem, and then lemma are used to prove this theorem or proposition, because maybe you need to have some intermediate step before you can prove the big theorem. Okay. Claim is somewhat like lemma, like that, but maybe it's just very trivial one. So I claim it, easy proof. The proof is left to the reader. People like to do this job to mathematician. And what is corollary here? So corollary come after theorem. So something very easy to be deduced from what we know. Not much proof involved anymore for corollary. And we just use what we know. Just use the statement of the theorem. And we don't need to invoke new idea. This is what we call corollaries. Okay, make sense? So this is the idea of flow. Okay. Maybe you think that I don't study pure maths. Do I need to care about this? Yes. This is how people think. 很简单啊，就是跟着那样下来罢了。This is corollary. Okay, something that's very hard to deduce. 哇，不懂哎，这么是对的。Theorem, you need to prove it first. 我觉得是对的嘞。Conjecture. Does that make sense? Okay, so in real life, people actually are using this idea over and over again, but just that they didn't quantify it. But we mathematicians make it precise. Okay, clear with this word? Okay, we will frequently encounter this, maybe less in this class, but in future you will see it again. So next, obviously we need to prove them. Okay, so these are proof. Sometimes we won't prove it. So sometimes we just sketch the idea. Okay, and sometimes we will do some check, which we call a sanity check. If I claim something is true, better you check. Okay, check on some examples. Okay. So how many type of proof you know? So you can prove it directly. So you have a direct proof. So you have a contradiction, or you have a contrapositive. Okay, so these are the main tools we're gonna use. Okay, so last two. So 6. Sometimes I will fix some notation. Okay, so notation is very important. Okay, notation, integration sign, differentiation sign. Okay, even for differentiation sign, we have a few of them. For example, what? D over dx, sometimes I put dx like that. So all these things mean the same thing, so you need to know. Okay, I will talk about them when we introduce it. Okay, in particular, we are vector calculus, so we are working in multivariable calculus. Okay, I give me 5 more minutes, I'll give you a break. Okay, give me 5 more minutes, I'll give you a break. 7. 7 is some extra comment. Okay, comment about the definition of theorem, so on. So this is the thinking process. Okay, this is the thinking process when you learn a new stuff or new theorem. Does it make sense? Yeah, so if I miss any of them, you can ask me, hey, Seng, why you want to study this? What's the use of this? We go back to first line. When can we use it? Go to third line of example. Why is it true? Approval. Other than that, still useful or not? Okay, go here. We use another base. Okay. Okay, how do we write it up? Okay. Notation. Does that make sense? Okay, so this is the general tone for this class. Okay, so for this class, we will be a bridge between arithmetic and mathematics. So when I was in Australia, right, we straight away go analysis. So we straight away do MA1. You know MA1? This is what you're going to learn that semester. We straight away go epsilon delta, but we are not doing it here. So this will serve as a bridge between pure maths and this arithmetic calculation. Does it make sense? So that when you go MA1, you won't be very surprised because you already know how to calculate. Then in that course, you will learn abstract idea. Okay, so far any question? Any question before we break? Or maybe 10 minutes. So every hour we'll break for 10 minutes and then resume. Okay. No question, huh? Okay, so before next class, I will take attendance. Okay, so let's break for 10 minutes until 2:15. Okay. Ah, 等下，没事，去厕所去。 attendance before we start. 邓李全瑜 How do you pronounce your name? 邓乐川瑜 OK 李建彤 OK 文永仪徐小鹤朱金胜 Chua Chen Yu 林之印 Paul Bing Xiu Paul N Qi Is it correct? N Qi Chang Yu Wong Qiu Yishen Chu Bongping Cao Chunxiang Is it correct? Cao Chunxiang yeah. 李玉亮刘慧琪恩凯论恩凯牛一相 What's the surname for Neo? Huh? Liang. Liang. Oh, like the Liang Zhiqiang. Oh, okay. But Liang Zhiqiang is NEO, right? Liang Zhiqiang, NEO, right? I think it's NEO. So, okay. So are you Hokkien or what? Hokkien, I think, yeah. Liang Zhiqiang should be Hokkien. Wong Zitian. Yeah. Ang Wei Chen. Kong Hambo. Xiaoying. Yeah. Tuan Chi. We already called you. Yeah, right. You asked about that. What advantage you get, right? So in my university, right, they actually offer pizza. Yeah, every semester, right, they will have a meeting of class rep. From every classes. Hey, so what's his name again? Li Jiantong. Yeah, just now we call you Li Jiantong. Yeah. Okay. Yeah, we have a semester class rep meeting for all classes. So they have feedback to in some course coordinator, okay, for mathematics. But here we don't have it yet. Okay. I think I started. I'm not sure. I think the other class also have some similar roles, but not formal yet. Maybe in future we will make it more formal. But I want to start it in my class at least. Okay. Yeah. Who want Jinsen? You want or not? Very easy one, nothing to do one. Your friend ask you, huh? Can okay. So we got one Jinsen. Oh, the other one? Quan Yu, you want to know? Are you Quan Yu, right? Quan Yu, do you want? Nothing to do one, very easy one. Just call it. Okay. Okay, good. Okay, can both of you before they leave later get them all their content add into a team chat. Okay, make a class team chat so everyone can discuss informally there. Whatever you want to discuss related to this course one, or you want to do some outing or a discussion also can. Can or not? Both of you. Wait. You know what do you need to do? Add all of them here into the group team chat. Okay. You can add me also, but maybe I'm less involved. But if you tag me, I will reply you. Yeah. Okay. But basically, want to get a faster way to reach you guys, other than email or folder announcement. Because every day you guys sit together, right? Should be sitting together. Same class, right? Yeah. Easier to approach. Any one of you is not in this batch, what's batch in this? 2404. 2404. Anyone not this batch or not? Or taking this course? Same batch, same course, only you? Only you are okay. Yeah. So you need to be a bit to their news, because your other course not with them. Okay. Yeah. Yeah. Please add everyone here. How many of you are? 21. Okay, must see 21% there. Is it 21? 21. Oh. Yeah, 21. Hey, why is it missing? Eh, 21. Oh. Huh? There's 21 here, but there's no 2%. I mean, 2 absent. Oh. Anyone I didn't call your name? I didn't call your name. What's your name? Wang Xiaoyang. Are you in the system here? Can you email your student ID and the name to my email? Yeah. Then still got one more guy. Because there's 2 absent here. Wen Yongyi, Wang Zitian. Here got 21, right? Minus 2 should be 19, right? Plus 1 is 20. Plus 1, 20. Oh, that's correct. 19 plus 2. Plus 1. Yeah. Okay, good. Okay, correct. Is it correct? So here got 19, right? 19 plus an extra is 20. Correct. You see, I cannot calculate properly, so you need to help me check. So here got 21. These two. So you got 19, 20. Which two? Oh, you are not in the system also. You didn't tell me. So you have to email your name and a student ID to me. Okay. So that I have your record. Okay, then that's correct already. Missing two. Okay, so let's start our class. So in the Moodle, you will see this preview, not right? So you can use that as a guideline. Okay, I might use it or I might not. Okay, so you can how to say, do preparation based on this. Okay, so in principle, you have to read advance. You know what it means? Before class, you read. You don't want to read also can. I have students that didn't do notes also get 100 in my class. It's possible. But if you don't come in my class, blah, blah, you don't know, then that means you need to read first. Okay, so I already post out the past year lecture notes. You can also read first. Okay, it's not that, I read, I understand, 不用来了，那反正我都懂了，都有了. It's not like that. Okay, so you come here, you read, this part I don't understand. Come here, ask me. Okay, so this is the chance for you to meet me here. You pay for tuition, right? Okay. I'm okay if you go and learn this Indian guy with YouTuber. It's okay one. This is a very good source. Do you know Indian guy YouTuber? You know, you don't know? Your classmate maybe can tell you. You can learn all. Billy also can. Also can everything. You go and learn it. Learn. Okay, come back. Ask this part. Hey, I still don't understand what I'm saying. Okay, no. So I don't see them as a threat or what. So these are all reference for you. Okay, these are very good reference for you to learn new stuff. 不是从一个人听来是就是是不是这样人家会骗你的人家不一定骗你，但是他可能也会错。So we need to do cross reference. So that's why I put a lot of reference for you. So you need to check. This is what these people say for you. And textbook also got mistake, you know. Solution also can be wrong, you know. So you need to do cross check, okay? Does that make sense? Okay, don't just believe on one source. Never believe on one source, including me. Okay, including me. So this is how we do research. People don't understand, students don't understand. 研究有好做咩？全部都找出来了不是咩？No, this is not true. Okay. This is not true by Gödel's incompleteness theorem. Do you know Gödel's incompleteness theorem? None of you. Is it introduced in discrete math or not? Gödel's incompleteness theorem. Huh? Don't know. This is a very important theorem in mathematics. It says that in every mathematical system, you can come up with a statement that you cannot prove with the language of that mathematical system. So what does it mean? You need to come up with a new system. New system still have statement that cannot be proven. New system again. So there's non-ending job. Okay, so research is a non-ending job. Yeah. Okay, cool. So let's start. Okay, so let's start our real business here. So before we start, let's give some overview of this course. So 我这个人是这样的，我希望给人家重点 target. I tell you where we need to reach, and then we will work towards it. Okay, so let me give you an overview first. So our course is based on vector calculus. So what's the idea? When you see vector calculus, these two words put together, what does it mean? What do you expect? Very good. It's a calculus plus linear algebra here. Okay, but still mostly it's calculus. Yeah. Mostly it's still calculus. So it just calculus appear few times. Okay, like 3-dimensional, then you need to do 3 times on. And yeah, 3. That's all. That's the only linear algebra we need for now. Okay. If you go to MA2, then you will need abstract notion from linear algebra. Here's just calculation. Calculate. Maybe in calculus 1, you calculate 1 time. Here you need to calculate 3 times. So that's all. In R3. R2 calculate 2 times. That's all. Okay, in our class. But in MA2, you need to prove some statement, then you need real linear algebras. Okay. So let's start with a very easy thing. So which is rectangle. Okay. Whenever calculus see rectangle, what do you want to do? Huh? What do you want to do with it? The idea not. Yes. What do you want to do? Calculate the area. Okay, very good. What's the area of the rectangle? Huh? Good. Say louder. I didn't hear it. Someone say something. How to calculate? Hey, don't be shy. This one is a primary school. I haven't come university yet. This is primary school. Right? Don't be shy. Don't be shy. I want the area of this. Length times what? Width. Good. So you decide one is length, one is width. But in a university level, what do? You put this rectangle on a what? 2D space. Okay, you put it on a 2D space. So instead of just length times width, what do? You realize the length as a function. Okay, you realize it as a function. For example, let's say this length is 2. So you fix fx equals to 2. So the length of the area of this rectangle become a area under the graph of a constant graph, for example. Does that make sense? So what's the benefit of doing this? What's the benefit of doing this? 什么好处？ What's the benefit of doing this? One way of going to Riemann integral, you learn Riemann sum, right? Is you can calculate area with irregular shape. And you can calculate area with irregular shape now. Okay, not just rectangle. Does it make sense? Okay. Okay, so what's the big deal here? So now we're gonna leave this Riemann integral on two-dimensional. Okay, so we will do calculus 2 here. So what is calculus 2 here? By the way, this one is just idea, So try and follow my idea. This is just overview, nothing technical yet. Okay, so what we're gonna do in calculus 2 is we need to deal with real life. Okay, what's the real life dimension you live in? Anyone have any idea? What's the real life dimension you live in? Okay, you can move forward, you can move sideward. Okay, if you have a wing, you can fly in. Okay, birds can fly. Very well. Okay, so there are 3 dimensions here. So, in 3 dimensions, you can work out a path inside this 3 dimensions. In this case here, you also can figure out the area covered by this path here. Okay, so if you look at this area of this path, what can you think about it? You can think about the curtain like that. Does it make sense? It's like a curtain, right? Irregular. Okay. Okay, good. We can do more. So on 2D, we look at line. In 3D, we not only can look at line, we can look at a surface. Okay. Can you imagine what else we can compute from this kind of method? Can you imagine? What if we replace this line with a surface? So in mathematics, we start with the easiest one first. Okay, we talk about function, we start with constant function first. Y equals to x is not the easiest one. It's a linear graph. The easiest one is a constant function. So similarly, we can put a constant surface. What's a constant surface? Like a piece of paper, flat. Okay, flat. So maybe we can consider this. Okay, so if I compute area under this surface, what is this actually? What is this? If I can compute area under this constant surface, what is this actually? What is this computing actually? Volume. Okay, actually it's volume of a box. Make sense? Okay, so this is what we're gonna learn until the end. We will build theory up to the end. So, like line, like a constant graph and an irregular graph, what we can do here, we can perturb this constant surface. If you perturb it, what do you get? You know what is perturb? You change the height a little bit. You vary the height. Okay? You vary the height. Any example in your mind? If you vary the height, what do you get? It's like your shirt. Your shirt, when you fold it, it's a flat thing, right? But when you wear on your body, then this shirt will look in different height. I don't know. Even you have the same shirt wear on different body, also have different, also occupy different height or spaces. Okay, so we can replace this constant surface with irregular surface. So for example, what can you imagine? You see, I keep asking you to imagine. So mathematics needs a lot of example. So what can you do is you can imagine a mountain, correct? A mountain. So you can imagine a mountain, let's say this way, right? So you have a mountain here. Then you can think of it a mountain, right? So instead of thinking about this flat space, you can think about like mountain. Does that make sense? Okay. So if you want to, let's say, if you want to compute a volume of a volcano, what do you think? You put a big piece of paper on top of the volcano, and then you compute the volume under the surface. Does it make sense? Okay. Any question? Ask, please ask, please ask question if you are blurred. Because I'm not talking any technical now. Just idea only. If you are blurred, please ask. Any question? 听真懂 better No, can get okay. Please make sure what I said makes sense. Otherwise, we will lose contact. Okay, so right, we can get the volume, but we want to do some detail stuff. So meaning we want to look something more closely. So for example, let's say we see closely around here what happened. We cut it. We cut it around one places. So we want to look at it. What we say is locally. Okay, 本地. Okay, it's like you stay in Malaysia, but actually locally you are just in Sepang. You are not technically in whole Malaysia, right? Okay, so it's just locally here. Okay, what happened locally here? We can take a slice, cut it. Okay, so let's say we cut it in this way. So let's cut it in this way. So let's cut it. So let's how to say, put here x y z. Okay, let's look at the xy plane. What happened to the xy plane? What happened to this mountain here? Sorry, I shouldn't do x and y. Can I do x and y? Maybe do x and z. Okay, let's do x and z. Okay, so let's say I cut it this way, and I saw that my mountain look like this. Make sense or not? Okay. Okay, let's say my mountain look like this. So I want to see what this actually is. Okay, how curvy is this? Okay, how curvy is this curve here? So what do? I also don't know how to do. So I use the easiest thing. What's the easiest thing? Constant. Okay, I also start with constant function to find this, estimate this graph here. So maybe we start with which constant function is the easiest, convenient one. Maybe I choose this one. I choose this one. So this is a tangent, for example, tangent line at x equals 0. Okay, why do I choose this one? This is a very valid question. 为什么？周末不可以选这个？周末不可以 ？Can you can? But I think that this is more convenient. Why is it more convenient for me to choose this one? If I want to explain all the other points, what do I do? What do I do? How do I start from the blue line to the orange line? You take a string, right? You take a string and then you just bend it. Correct or not? You take a straight line, you bend it. Alright? You take a straight line, then you bend it. But what's this bending process here? What do you do actually? Okay. Again. Even integration. Not quite. Not quite. What do you do? Let's say, for example, let's say, give you an example. Let's say this is y equals to 1. And then this is y. So let's say y1, y2 equals to x squared. Sorry, should be minus x squared plus 1. Okay. So how do you get from even the same x? How do you get from blue line to orange line? Yes, you minus something, right? Okay, at different point further away from 0, the more y value you need to take away. So how much you take away from 1? You get what I say? So let me draw here. So let's say this point here. So this is on the same y, same x. So how much do you need to take away? For example, this point here. How much do you need to take away? Depends, right? Depends. Okay. But I tell you the equation for these two curves already. At x equals 0, what do you get? 1. This graph starts at 1. So at x equals 0 there, Agree. Okay, so this is what is being drawn here. But away from x equals 0, you can see that the value of y you take is the difference in y is getting larger. What's the rate? This is the rate. Minus x squared plus 1. So you need to take away minus x squared. Okay. Does it make sense or not? For question, please ask. Why not z? What's that? Ah, thank you. Thank you. So this is just a name. Okay, I can name it as Z1 and Z2. So maybe name it Z1, Z2 is easier, but that's fine. Okay, it's just some. I can put W also. I mean, I need to tell you that W take value here. So put Z is a more convenient way to do it because we know that this value lives in Z axis. Okay. Does it make sense? Okay, but there's another way of getting it. Okay, there's another way to get this equation here. Okay, so there's another way to get this equation. So if you look at Z1 prime, okay, this is what you don't know. You just listen is enough. Okay, don't get blur because later I will introduce this. So what I can there's another way to obtain this Z2 here. Okay, there's another way to obtain this Z2. So what you can consider is you consider Z2 prime. Okay, if you differentiate once, what do you get? Minus 2x. Okay, and then if you differentiate twice, what do you get? Minus 2. And then if you differentiate more, you just get 0. Okay, but if you consider this series here, let's say Z2 at 0, Z2 prime 0 times x plus Z2 prime 0 over 2 factorial times x squared. What do you get here? What do you get here? So if I evaluate Z2 0, I get 1. At Z2 minus, so I have minus 2 times 0 times x, okay, and then plus minus 2 over 2 factorial times x squared. And altogether, I reproduce my function Z2 again. Okay. Maybe some of you have seen this construction. Anyone seen this construction before? Taking derivative and then add them together. You know, have you seen this? You know what it calls? Yes, Taylor series. Okay, so first chapter we will reach is Taylor series. Okay, yeah, it's okay. You don't know why is this true. I just want to give you a brief idea how to put things together. Later we will relearn everything again. Okay, using definition. Okay, good. So good. So this is Taylor series. So the end of this chapter is Taylor series, first chapter, and then the end of the semester is this big volume or area. Okay, in higher dimension. The highest we'll go is 3 dimension. Okay, 3 dimension. Object in 3 dimension. Actually, we live in 4-dimensional space. You know? How do you know? Time. Okay, very good. So we might see time as another dimension. Okay, but there's some controversial thing about this time being another dimension. Because if you think about dimension, what do you know about dimension? In linear algebra. Actually, this is the fun thing about linear algebra. What can you do in linear algebra? You can take scalar multiple. For now, what do you experience? Times can only go forward. So what is negative time? Do you mean you can go backward or not? In time? Okay. Yeah. If you go backward, how do you go backward? Is it like if the pen drop like this, if you go backward, you have to go like this? Or you straight away reach the previous time? This is a very interesting topic, you know. This is being discussed in Tenet. You know Tenet, a movie. Tenet. It talks about time travel. Huh? You know Tenet? What's Tenet? Yeah. Tenet. Yeah. Tenet. Yeah. Okay. Yeah, it's very interesting. It's being still being researched on about this fourth dimension, but we can't really draw fourth dimension actually. Can you draw it? If you draw it, please tell me. If you can draw it, please tell me. Okay, so all these are we cannot draw any dimension after four dimension. Okay. Right. Because our geometry intuition is living in 3D, correct or not? We move front, move side, move up. But where is the fourth dimension now? Hey, actually, you experience this every day, you know. Actually, you experience this every day, you know. You control a four-dimensional thing inside a two-dimensional object. You know what is this? Yeah, YouTube. Four-dimensional thing inside a two-dimensional object. Correct or not? Your phone, your computer, you can scroll back the time, right? Yeah. Wow, so nice. Correct or not? Yeah. So you have some experience with these things, but how to make it rigorous, that's the other thing. Okay, so let's not dwell on that too much. So let's start. So the first chapter we'll get to is chapter 11. So if you notice that we didn't follow the order in your textbook. So there's a story about this. When I first time taught this course, right? The other course was a series, not series, the probability by, you learn probability in this semester, right? So that time was taught by Tao Shen. Tao Shen asked me to rearrange this so that you can use the probability. So you should expect this series coming soon in your probability. But it's not Tao Shen anymore, but I'm not sure now. But it will be used in probability then. Okay, so we'll start with infinite series, sequence, and series. So to talk about series, right, you want to add terms. So what are the terms called? Okay, so basically we'll start with sequence first. So for the purpose of this class, we will fix our natural number. So I write this n here as our natural number here. So natural number, we start with 1. Okay, no? So when we talk about natural number, we'll start with 1. If I want 0 inside here, I will specify. So how do I specify? I'll write it as, let's say, n0. Okay, it's 0 union d set. So 0 union n. Okay. So for the purpose of this course, when we talk about natural number, we start with 1. Okay. Do you know what is a natural? 自然数。为什么自然 ？Why? Okay, you can count with finger. Usually you count 1, right? How do you count 0? I mean, there's nothing how you count. You must count this. Like there must be something for you to count, right? So you must at least start with 1. This is what I meant. Okay, so it's natural. So you just start with 1 pen, 2 pen, 3 pen, 1 apple, 2 apple, 3 apple. And so this is natural. Okay, and then we will go to integer. Right? Integer and then rational number and then real number. Okay, so let's start with natural number. So let's end with this definition before we finish the class. So we'll start one definition. There's only one definition you need to learn today is a sequence. So what is a sequence? So a sequence, so the notation is A1, A2, A3, A4, so on, is important stuff. Is what? Is a list of numbers written in a definite form. Okay, so you say, hey, he's saying what number? not precise here. Numbers，什么 numbers？什么 number 都可以咩？啊，确实什么 number 都可以。Okay, so what number we consider here actually are the real numbers. Okay, I think we won't define real numbers, but basically the rational and irrational. You know rational, irrational? You know, you know what is rational? Number that can be written in the form of P over Q. Okay. Irrational? What's irrational? For your standard, for your level, you just need to remember like pi, exponential, and then what's irrational? Golden ratio, square root. These are irrational numbers. Yeah. And combination of them. Yeah, linear combination. You can add them, you can multiply them, you can scalar multiply them. Okay, they are irrational. Does it make sense? Okay, but to be precise how to define rational, irrational, we need to go to MA1. Okay, but for now, remember this example. Does it make sense? So, yeah. Okay. So what are the other notation here? We also can write it as curly bracket, the set bracket an, n equals to 1 to infinity, or bracket an. Also, what are these an? We call this an to be the nth term. Okay, nth term of the sequence. An. Very dangerous. We write like this. Confuse. Okay, these two things. So how to make this rigorous here? So sequence we usually write bracket an. Okay, but one problem here is I'm not sure you learn in discriminant or not. You cannot reuse the index here. You know what is reusing? This n is pointing to a fixed n, but this n here is a general n, general sequence. So to prevent this, what we can do for the fixed here? Maybe I just put ai and ith term, okay, of some sequence. Okay, so make sure you don't reuse symbol in mathematics. Does it make sense? Don't reuse, because this I is referring to a specific I, but this n general sequence. Okay. Does it make sense? Okay, so be careful. This is very helpful in your assignment. Okay, let's give some example here. Give some examples. Example of sequence. You want to give some? You want to give me some examples? Sequence that you know. Okay, let me start with one. Maybe 1, 4, 7, 10, 13. Do you want to guess the next one? 16, good. So this is like a kindergarten question, right? Can talk. Okay. Yeah, so this is sequence. We only look at meaningful sequence. If you simply put number, I also cannot guess what is the next one. So there's a what formula here. Can you think of a formula to describe this sequence here? Can you think of it? Think of one. Anyone guess one formula? After you guess, we can finish the day. Guess a formula. So what do I mean by guess a formula here? So you should tell me what is the formula for an. Okay, for example, if I put n equals to 1, it must output 1. If I put n equals to 2, it must output 4. If you put n equals to 3, it must output 7. Can you think of a way to do this? Good. So you can check that 3n minus 2 should give you the sequence. N start from where? 1. Good. So n live in where actually? Good. So actually n is living in natural number. So from here, what can you see? From here, what you can see is an. The an we describe is a function from n to r. Okay. So a1 was a number, a2 was a number, a3 was a number, a4 was a number. Okay, so this is sequence. Okay, this is a formula for that sequence. Another way we can describe this formula is based on previous term. So what do I mean by that? So you can similarly define a1 to be 1, and then an to be an minus 1 plus 3 for n greater than equal to 2. Okay, so what we call this is a recursive formula. So having said this, still don't believe me. What do I mean? Do sanity check. Check. So plug n equals to 1. Do I get 1? Plug n equals to 2. Do I get 4? 7, so on. Same for here. A1, is it 1? Okay, I already defined as 1. 2, you need to check. A2 is what? A2 equals to A1 plus 3. So A1 is 1. 1 plus 3 is 4. So you get 4. Okay, so this is called recursive because we define using the previous term. So I need to start somewhere. So this is what we call the base case. It's a bit like the inductive hypothesis. You need to start somewhere first. Okay, so this is called the recursive. Okay, you run it recursively. Okay, so these are basically 3 ways to define sequence. Okay. Any question? Any question before we break? Any question? Yeah, so this one definition are very important. Very important. So moral here is we actually see sequence as a function. So this is the level you are different from kindergarten, no? Right? Kindergarten only can pick, only can guess number. But what you think of it is actually a function already. So how to think of a function? When n equals to 1, you can plot 1. 2, you can plot 4. 3, you can plot 7. But this graph is discrete, no? It's not connected. Still considered as a function. Make sense? Does it make sense? Okay, so we will revisit this again on Friday. Okay, so before we break, make sure the class rep Chen Yi and Jingsen get all the details, the contact here, add them into a team chat. Okay. Any question before we break? Last question before we break. Any question? Please ask. Chen Yi, got question? Oh, okay. Okay, yeah. Don't be afraid. Just ask. Okay, you don't understand, just ask because you are new. So you, yeah. Okay, so see you on. Okay. Actually, Teams 比较容易 ，Yeah， Teams 可以这样子加。可是你刚刚讲什么？他们说跟 Teams 哦，你们觉得 WhatsApp 比较好？你问问他看。全宇，你们要用 WhatsApp 还是要用 Teams？Teams 比较好吧？我觉得。我觉得 Teams 比较好，比较每个人一定会有。对呀，对呀，对，用 Teams。Teams 之后全部大家都有。叶OK.
She actually transferred to another school.
Oh, she transferred already.
Yeah.
So 我们之前 transfer 她。Okay, I will make a note. Okay, thank you.